Exercise 1.4-9 sum, you have to solve these three non-homogeneous linear equations using determinant method. So this I would say is ideally a 10-mark question, not asked often, but yes, you can expect it. It is an important question. So before that, let's start. Whenever you have you have to solve linear equations which have 1 by x, 2 by y, 3 by z or something like that, where you have the x, y, z in denominators. So the best thing would be to make some very simple assumptions. For example, you say let a is equal to 1 by x, b is equal to 1 by y, c is equal to 1 by z. So by doing this, it becomes easier to solve these equations. So when I'm going to substitute these assumptions in these equations, this becomes a plus 2b. Why 2b? Because 1 by y is b, therefore 2 by y is 2b minus c equal to 1. The second equation becomes likewise 2a plus 4b plus c equal to 5. The third equation is 3a minus 2b minus 2c equal to 0. Now you have to solve for a, b and c using the determinant method. And determinant method, we very well know the formula, right? Anyway, let's write it down. Del a is equal to, a is equal to del a by del, b is equal to del b by del, c is equal to del c by del. So the first step is to find out del, ensure it's not 0, then find out del a, del b and del c. So can we find out del first? So del would be nothing but write the coordinates of a, b and c. 1, 2, minus 1 from the first equation, 2, 4, 1 from the second equation, 3, minus 2 from the third equation. So if you expand and write, if you find the determinant, right, it will be 1 into minus 8, minus of minus 2, so it's plus 2, minus 2 into minus 4 minus 3, right, and then minus 1, hide the corresponding row and column, you get minus 4 minus 12. So it is minus 6 plus 14 plus 16, which is 30 minus 6, 24. And see that 24 is not equal to 0, so we can proceed to find del a. When you find del a, in the column of a, you will write the resultant matrix, right? 1, 5, 0. The resultant value you will write 1, 5, 0. In the column of b and c, it will be the same values. Only in the column of a, we should put the resultant matrix value. So it will be minus 1, 1, minus 2. Now, shall we find this out? It will be 1 into minus 8 plus 2 minus 2 into minus 10 minus 0, so it's just minus 10, minus 1 into minus 10 again, so it's minus 6 plus 10 plus 20 plus 10. So the answer is plus 24. So del a is also 24. So likewise, can you find del b and del c? So for del b, in the column of b, we will write the resultant matrix 1, 5, 0. And for the c column and a column will be the same, 1, 2 and 3. Now let's expand. What do we get? 1 into minus 10, minus 1 into minus 4 minus 3, minus 1 into minus 15. So did you get minus 10 plus 7 and plus 15? So you must get 12. Okay, now let's proceed to find del c. So we are almost nearing the end of the sum. So for del c, how will you write? Yes, correct. The resultant matrix you will write it in the column of c. A and b will remain as it is. What was B? 2, 4 minus 2. Now let's expand this and find the determinant. So it is 1 and 2, 0, minus of minus 10. So it is plus 10. Minus 2 and 2, 0 minus 15. Right? And the last one is plus 1 into minus 4 minus 12. So what do you get there? 10 plus 30 minus 16. Right? And the answer is 24 again. Right? So, what is A? A is nothing but del A by del, which is nothing but, what was del A? 24. Del was 24. Therefore, A is equal to 1. Likewise, B is equal to del B by del, which is 12 by 24, which is equal to 1 by 2. Right? And C is the same as A, right? Del C by del, both was 24. 24 by 24, so it is equal to 1. Now, the sum doesn't stop here because we have to find X, Y and Z and not A, B and C. Right? Therefore, what did we assume? Let A be equal to 1 by X. Therefore, X was equal to, X is also equal to 1. Then we said B is equal to 1 by Y. That is, 1 by 2 is equal to 1 by Y. Then you cross multiply so that you take both up to the numerator, you get Y is equal to 2. Likewise, C is equal to 1 by Z. Therefore, you get Z is equal to 1 because C was 1 anyway. So that, therefore, you get the solution as X, Y and Z is equal to 1, 2, 1. Right? It's relatively easy to do sum. So don't miss out on this if it comes for 10 marks.